So once our solid has dissolved in the solution we're preparing, now we are ready to measure the pH of that solution. And for that we can use the pH meter, which has already been calibrated. It's important to pay attention to the electrode that we have that will measure our pH. This electrode is a combination electrode that has a glass bulb at the end over here. So here we have what is called a combination electrode, which consists of two electrodes enclosed in a single probe. This is the black part we see in the figure to the right. The pH-sensitive electrode is enclosed in a tube ending in a glass bulb, shown in red. This bulb is permeable to protons. The reference electrode is a ring-shaped chamber surrounding the pH-measuring electrode and consists of a silver wire immersed in a 4-molar KCl solution saturated with silver chloride. The outside wall of the reference electrode has a membrane junction, which closes the circuit between the two electrodes by establishing an electric contact through the sample solution. This is the white dot we see on the probe in the figure to the right. Therefore, it is essential to keep both the glass bulb and the white dot immersed in solution at all times. The amount of protons diffusing across the glass bulb and reaching the pH measuring electrode is proportional to the concentration of protons in the sample. The voltage difference between the two electrodes reflects the proton concentration of the sample and thus allows us to measure the pH of the solution. So with every measurement we make, we have to make sure that we rinse the electrode with distilled water, and then we wipe it dry with a tissue, and make sure you do it very gently, especially be careful around the glass bulb. And now we can immerse our electrode into the solution and make sure that the white dot and the bulb are both immersed in the solution, as well as the stirring is continuous with the magnetic stirrer. And now we see that the pH measured is 4.59. Supposing we need to adjust our pH, we need to use an acid or a base to add to the solution to modify our pH. So for example, if I want to increase the pH of my solution, I would have to add a base to the solution and always to keep the stirring going. So we add a base of different concentration to change the pH of the solution. And we see that as we add the base, the pH is increasing on the screen. And let's say I want to go to a pH of 6, then I'll keep on adding base slowly till I reach 6. To take a measurement with the pH meter, we need to wait till the measurement stabilizes on the screen, and that's indicated by the word stable that appears on the screen, and it will tell us that the measurement is stable at that point. After we finish our measurement, we need to take the electrode and rinse it with distilled water, and then we dry it with a tissue very gently. And it's very important to keep it immersed in a buffer solution because we don't want it to dry up in the air. And that's how we store it between measurements. Just a reminder that after you finish measuring your pH, to add up your solution to the final volume, so in this case it's 100 milliliters, so we have to use a graduated cylinder or a volumetric flask. So here we will show you how to calibrate the pH meter. In general, the pH meter will be calibrated for you, but if it wasn't, you will not be able to see anything displayed on the screen at this column here. If it was calibrated, then you will see the different pHs of the different buffers that were used. In order to calibrate our pH meter, we need to press on the button STD or standardize, and this pH meter allows us to measure different pHs of buffers. So we'll use pH 4 and a pH 7 and a pH 10 buffer to have a bigger range of pHs for measurement. When we press on STD, the word will change to standardize, and then we'll be able to calibrate. So what we need to do to calibrate with a pH of 7 is to get the electrode from the buffer and we rinse it with distilled water. Then we wipe it dry very gently, and then we insert it into the pH 7 standard solution. And then we see that the pH will vary a little bit until it stabilizes. And then we see the word stable appear. When it stabilizes, we need to press on STD, standardize, and the pH meter will find the standard we're using. So now it's stable, and we press STD, and we see that the pH meter was calibrated to 7.00. And we see that the word will change to measure. So if we want to calibrate with another standard, we need to press on STD again, and we start with another pH. So now we're gonna calibrate with a pH of 10. So we rinse our electrode and dry it again very gently, and then we insert our electrode into the pH 10 standard solution. And again, make sure that the white dot and the bulb are both immersed into the solution. And now we're gonna wait till the pH meter will stabilize on a pH near 10, and when it's stable, we can press on STD. When we calibrate the pH meter with 2 pH units, the meter will give us a slope measure, a percentage. It's important that the slope be between 90 and 102%. It will indicate a functional electrode and a functional pH meter. So here it shows us 97.1%, which is very good. And we see that the pH meter shows a calibration with pH 7 and 10. And then it says good electrode at the bottom of the screen, which indicates that the meter is working well. Now the next thing is to calibrate with pH 4. Using the 3 standards will give us a wider range for measuring our pH. So now we will do our final calibration with pH of 4, and we will press on the button STD and wait till the pH stabilizes around 4. When it's stable, we press on STD again, and we get a measure of the slope, a 92.7%, which is very good, and will tell us that the pH meter has been calibrated properly. So we see a pH 4, 7, and 10 calibration on the screen, and now we can use it to measure our pHs of solutions. Remember to rinse your electrode and dry it, and put it back in the appropriate buffer after every measurement.